Hey everyone, we're going to look at number 3 in section 3.1. We're going to simplify the difference quotient, which they have written this way. This indeed is the difference quotient. When f of x is this function, this should be 3 plus 2x minus 5x squared. Sorry about that. So again, your function that you're given should be similar to this one. And so first of all, we're just going to simplify, and then the second part of this is to actually find the derivative. And I'll explain that here in a minute, to find the derivative at x equal 3. So what is f of x? Of course, it's just the 3 plus 2x minus 5x squared. What is f of 3? Just replace x with 3. And if I go ahead and evaluate that, I get 3 plus 6, which is 9. 9 minus what? 5 times 3 squared, 5 times 9 is 45. So 9 minus 45, I get negative 36. So be careful in simplifying that out. I've got 3, 2x minus 5x squared minus a negative is positive 36. So be careful there. Okay. Over x minus 3, I don't do anything to the denominator. Now, by simplifying, what we're going to do is see if I can find a common factor of x minus 3 up top here. So I first need to simplify. I got negative 5x squared plus 2x, and then 3 plus 36 is 39. And now I want to factor this thing out. So first of all, I don't like this negative in front of my x squared term, so I'm going to factor out a negative 1. There's no other GCF other than plus or minus 1. So I'm going to pull out a negative 1 just to get me a positive 5x squared there. Of course, that makes this 2x to negative 2x and this 39 to negative 39. And then I want to see if I can factor this. Well, in factoring this, we're hoping to find a factor of x minus 3, and that may help. But if I just had to straight up factor this, I see that 5x squared, 5 is prime. So if it's going to factor, it's got to be 5x times x, right, to give me the 5x squared. And then the last two have to give me negative 39, which means one's positive and one is negative. And, the only factors of 39 are 39 and 1 or 13 and 3. And I'm kind of already thinking minus 3. So I would start with 13 and 3. And again, you could do, one is positive, one is negative. You can do plus 13 minus 3, or you can do minus 3 over here, plus 13 over here, or you can do positive 3, negative 13. So, I mean, there's 4 different combinations that you can do. This is the one that's going to work. And again, I'm thinking, hey, I'm looking for an x minus 3. Let me try that so that we make this positive 13. So 13 times negative 3 gives me a negative 39. 5x times x gives me the 5x squared. But does it work? The outer is 5 times negative 3, negative 15x. The inner is 13x, negative 15 plus 13 is negative 2x. So this is correctly factored. And then what can I do? I can divide top and bottom by x minus 3. And here is my simplified difference quotient. Okay, you could distribute the negative if you want to and get negative 5x minus 13, but there it is. Now to factor 5x squared minus 2x minus 39, if you're not sure with this trial and error method, you can also use the AC method. 5 times negative 39 is negative 195. The value of b here is negative 2. So in the AC method, you're looking for two numbers whose product is negative 195 that sum to negative 2. So they're obviously both opposite signs, and the negative one is larger in absolute value. The answer is negative 15 and 13, because negative 15 plus 13 is negative 2, and negative 15 times 13 is negative 195. So I've got 5x squared. I rewrite the negative 2x as negative 15x plus 13x, and then my minus 39. And then I factor by grouping, right? Factor out the 5x here, leaving x minus 3. Factor out a 13 from these last two, leaves me x minus 3. Then I can factor out that common x minus 3 factor, leaving 5x plus 13. So either way, you should be able to factor this effectively. Now, what's the derivative? Now, you use your answer to compute the derivative. So f prime of 3 is the limit as x approaches 3 of f of x minus f of 3 over x minus 3. And so it's just the limit as x approaches 3, since we found the simplified version of this difference quotient, right? And this function is continuous at 3, so I can just plug in directly. And when I do and compute, I get the derivative, which is negative 28. Okay, I hope this is helpful.